Let's wait a few more minutes in case people are still joining. I hope I'm audible. Uh, am I audible, everybody?
Yes.
Okay, thanks. Okay, I think we can start and people can join in. Let me just share my screen. Okay. Okay. So yeah, hi everyone. Welcome to this week 7 of this class on uh, joy of computing using Python. So as you all know, these are the solving sessions that we hold every week so that you can have some practice of solving not only problems for your assignment, but also your programming practice will also be there. And the goal of these sessions is that we can have some interaction because usually you're watching some recorded videos, but this can help you to have any interaction and clear your doubts in real time. So I encourage all of you that at any point, if you have any doubts, to stop me, or even if you want to discuss something unrelated to what I am showing but related to your class, you can again stop me and we can discuss that also. So yeah, basically this is the goal of this is to help you to solve your assignments. My name is Zenia. This is my mail ID, and as I said before, any doubts or any clarifications you have with me, you are always welcome to mail me. I'm not in charge of making the exams or correcting the assignments, so I don't have much idea about that. But if you have any subject related queries, please feel free to message me. I mean, mail me. I respond to my mails quickly. If I don't, just send me a reminder. Don't worry about it. This is my website where I maintain all the links of all the slides of all the sessions as well as the programs, and also the YouTube playlist where you can find the recordings of these sessions. So I think you all know all this by now. Was there something in the chat? I saw something in the chat. No, there's nothing in the chat. Okay, I felt like I saw something. So anyway, this time we are going to be dealing with your week 7 portions, and yeah, we are now at the halfway point of the course. So we are now going to little more complex programs because now you understand how basic structures like loops and recursive functions and all those things work. You can start to put them together into little more complicated programs. This week, for example, you are looking at the snakes and ladder, spiral traversing, GPS program, which all use different modules of Python. So once again, I'm saying Python is an open source language, and the beauty of Python is that it has a very good community, right? Who have developed different modules for dealing with different parts. So, for example, what is a module you used in your spiral traversing program? Can anyone remember? For drawing the lines and all, what is the module that you used? Can put it in the chat or you can say it. Does anyone remember once? Yeah. Does anyone remember what is a module? What is a Python module you had to use for drawing the spiral when you did that program in the class? Let me just. Are you guys there? Okay. Someone's typing. Yeah, cursor, but cursor was the function, but it had to be coming from some package, right? Like NumPy is a package. Matplotlib is a package which helps us to plot things. No, you did not use NumPy, right? Did you use NumPy to do the spiral? Did you use NumPy to draw the spiral? Any other answers? Yes, Turtle. Turtle was the name of the package, right? NumPy is a package which deals with arrays, right? So yeah, you needed, if you want to do numbers, you have to use an array, but you use Turtle because you wanted to draw a line and then you wanted it to go down and all that, right? So that's why you used Turtle. Do you remember now using the Turtle? Yeah, okay, cool. So I can see someone has given thumbs up. So okay, great. So the point I was trying to make is the beauty of Python is that it's fairly simple in its syntax, you know. You can pick it up easily, but once you pick it up, you can make it as complicated as you want. So Python can be as simple as you want or as complicated as you want. And yeah, there are different specialized modules that people have already coded up so that you can just use them. For example, I'm an astrophysicist, right? So I have to use a lot of data which comes from the telescope sometimes, and they come in a special format. So like how you have your JPEG files and your PNG files, for example, you astrophysical data comes in something called FITS files. That's the format we get the data in. So to process FITS files, you can write your own code, but actually people have actually developed a module called AstroPy, and AstroPy has all the functions, a lot of different functions, and it has a very easy function for you to deal with the FITS files. So I can just import AstroPy and then use it. So that's why it's very good to know as many modules as possible. And especially if you're working in a specialized field, like I'm an astrophysicist, so I know some astrophysics modules. Like there are some modules which are used for exoplanet searches, there are modules which are used for astrometric data, and so on and so on, right? So it's good to have an idea of these packages. And as I said before, always have an idea of going to the documentation, because every package will have some documentation. You can go there and you can search up and you can actually see what is the different functions, and you can actually read it, right? So that's a good way to get familiar with, because that's how practically you'll be using. Of course, for your exams or anything, you might have to memorize a little bit, but practically when you write a program, you will be going and referring, and you should be comfortable with going and looking at the documentation and so on. So anyway, these are the things you saw in this week's lectures. There's not much to say this week except, yeah, keep all these things in mind. Again, I'm saying I start with this every time because it's important skill to have as a good programmer is to also write readable code, not just efficient code which gets the job done, but readable code. Okay. Anyway, I think we can now go straight to the questions this week. I don't have any other like theory or things to share. Unless you guys have any questions about anything, we can go to the solving the MCQs of this week. Sorry, one sec. Okay, I don't think there's any questions. So let's go to the questions. I mean, there's any doubts from your side. So let's go to the questions of this week. As usual, I'll show the question and please put the answer in the chat. And all of you, please try and, answer. There are only 11 of you today, 10 of you, if I don't count myself. So, 10 of you can answer in the chat. I think that will be a good practice for you. Okay. So this is the first question. It's a little long, but just let me explain to you. So this is about this game, okay, where a player is moving their pieces around a cross-shaped board based on throw of dice. So this you might have played before, where you have to move a piece one by one and then remove pieces from the board until you reach the center of the board, right? So here they are talking about how you can implement such a game into Python. Okay. So they have given you 3 steps of how to put the sequence, or sorry, how are the 3 steps where you can define the program. Your idea should be to arrange these 3 steps in the correct order. Okay, so the first step, not the first step, one of the steps is roll the dice and determine how many steps the player can take and move the player's piece. Okay, the second is this, third is this. So second is creating a cross shaped board, blah blah blah, which is having this configuration. Third is check if the player has reached or exceeded the center of the board. If they have reached the center, then declare them the winner. So okay, I can see one person has already answered 2 and 3. Others, please answer. I want to see at least few people answering in the chat. It will be good. Okay, one more person says 2 and 3. Others? There are only few of you in the chat. I think, I mean, sorry, in the meeting. I think all of you can answer this question. Okay, one more person says 2 and 3. Anyone else? Guys, please interact. As I said, the point of these sessions is to have interactive session. If you are going to sit and watch this like your videos, then there is nothing special between this session and that session. Anyway, I will go to the answer. The answer is 213. Good. First, we have to create the board, then roll the dice and check how the player has done. So, I think you guys know how to roll a dice. I mean, how to simulate roll of a die now, because you have done it in your snakes and ladder program, right? Or you can just use random number generator for very simple thing. I don't know how exactly it was done in the snakes and ladder program. I didn't go through the whole program. So, was it done using random number generator, or did you use anything else? Yeah, well, you can use a random number generator. That's one of the ways that I was thinking is you can just use, 1 to 6, you can put the random number generation sequence and then it can always generate some random die through at every turn. Okay. I'm not sure how it was done in the snakes and ladder program. I didn't go through the full thing. So yeah, but I'm sure it was something similar that was done. Anyway, let's go to the next question. Okay. So here is a simple algorithm for the snakes and ladder game. So first you're going to create a board with positions from 1 to 100. You're going to define where the snakes are and the ladders are on the board. Each snake or ladder will connect between two squares. This you know. You roll the dice so that you can get random number. Okay, what I was saying, between 1 and 6. Move it forward if number based on the number, and check if the new position has snake or ladder, and then you have to move it to the next position. Then if you reach 100, then you declare them the winner. Otherwise, you keep on going it. Okay. So now this you already know. You already have seen how to do snakes and ladder in Python. Now the following variations were suggested for the algorithm. If you are using octahedral dice, so octahedral means basically it has 8 sides. So normal die has 6 sides. Now we're talking about 8-sided dice. In an 8-sided dice, we have to change step 2 to generate random number between 1 and 8. If we only have to change step 1 if we use a board consisting of 200 tiles instead of 100. Modification is required in both steps 1 and 2 if we use a board consisting of 200 tiles instead of 100. So please put their answers, which is the correct statements of A, B, and C. Please put your answers in the chat. Okay, maybe I can access the chat from my phone or something because I think it's blocking. Can you guys see? You guys can see, right? The question. Please put your answers in the chat. I'll monitor it from my phone. I hope you understood the question. So it's based on the normal algorithm, but what modifications are required if I want to change the game by changing, say, number of tiles or the dice, then what are the modifications required? Okay, I don't see any answers. Okay, one person says C. Others, are there answers? Sometimes my phone doesn't load the. Okay, only one answer. Okay, others, please answer. Yeah, there are only 9 people in the meeting, so all of you should answer. I can wait for everyone to answer actually. So I know that you're listening. Okay, one more person has said C. Anyone else? Others, are you listening? Are you in the class? Anyone else? Any other answers? Can only see 2 people, and it's always the same 2 people who are answering. Okay, fine. We'll go to the answer. I'm kind of disappointed. Please try to be interactive, guys. The answer is A and C. Good. So why do we need to modify step 3 also? Because of course, when we create the board, we need to now consist of 200 instead of 100, 1 to 200. And when we check for the winner also, it's not enough to check position 100. We have to check position 200. That's why 2 modifications are required. Okay. Next question. Okay. So Nishan enjoys the game of snake and ladders, but feels that the player should be given an extra chance if the player lands on a prime number tile. I'm assuming that you all know what prime numbers are. And assume that no prime number tile has snakes or ladders on it, so you don't have to worry about again jumping or coming back or anything. So he generates a following function to check if the position is prime. However, there is a chance that there is a small error in the code. Identify the line number. So you can see here there's 1, 2, 3, 4, 5, 6, 7, right? So which line is having an error if there is an error? Suppose you find that there is no error, just answer -1. I hope you all understood the question. So there is this code which is written to check for prime position because he wants to give one more chance to the person, right? So if there's an error, please answer which line number 1, 2, 3, 4, 5, 6, 7 has an error. If you don't find any error in the program, just put -1 in the chat. Okay. And I want everyone to answer this. Please, I don't want only the same two people who are answering every question to answer. Others also, please interact and be interactive. Okay, one person says -1. It seems like there is no error in the program. Others, do you agree? Okay, someone says line number 4. -1. There should be divided instead of percentage. Why should it be divided? Okay, we can see if you are correct. Okay, a lot of you are saying -1. Okay, interesting. So most of you are saying -1, and I guess this person says 4, and Vibay also says it's 4 because there should be divided. Okay. Can someone list for me what are the prime numbers, starting with the first prime number in the chat very quickly? I don't know if you're saying one is prime or one is first line is having an issue. Just someone list what are the prime numbers. 2, 3, 5, 7. Okay. Now check if this program is correctly checking for those numbers or not. Because that is the goal of this program, right? You forget about snakes and ladders and all, because that is extra stuff. This function is just for checking prime numbers, right? Just find out whether this program is correctly identifying at least those numbers which Jay has listed, 2, 3, 5, 7. If this program is correctly identifying that they are prime or not. And then try once more if there is really no error in the program or if there is. You guys understood, right? This function, you forget about snakes and ladders for now. Function is not to do with snakes and ladders. This function is to check if a number is prime or not. Of course, later Nishan wants to apply it to a snakes and ladder game, right? All you need to do now is find out if this function is correctly identifying if 2, 3, 5, 7 are prime, because that should be the goal of this function. Try once more, and if you still don't find any error, put -1. I'll give you 2 more minutes. Okay, so you are saying that the mistake is in line number 4, that it should be instead of double into. Okay. Any other answers, guys? Okay. Okay, I'll tell you what the answer is, but I want to see if you guys can work it out. What will this function return? If I give this as an input, what will it return? What will be the output? If I give is prime of 2, what will be the output? Can you put it in the chat? Based on this function, if I give is prime of 2, what will be the output? It'll be false. Correct. But prime 2 is a prime number, right? 2 is a prime number. It should give true, correct? Guys, are you guys able to follow? If I give is prime, if I run this function, if I write this function, I give is prime of 2, it's giving false. But 2 is a prime number. Why is it giving false? It's wrong, right? That means something is wrong with this. Exactly. The issue is in line 2. Because if you see there is a less than or equal to 2, what should the actual code be? Less than 2. Exactly. So the issue was in this line, they gave less than equal to 2, which means they are considering 0, 1, and 2 not to be prime. But we know that 2 is a prime number. So 2 should have been considered. Okay, so this is the thing. Now, I think one of you was confused with this part. Okay, so this is basically in when you check for prime numbers, how do you check for prime numbers, right? Suppose I want to find all the prime numbers up to say the first 100 prime numbers. So one naive way of doing it is, you go first check 1, divide 1 by everything, nothing. 2, you check divide 2 by all the numbers before it, nothing. 3, you divide 3 by all the numbers before it, nothing. 4, divide 4 by all the numbers before it. You'll find that 4 is not only divisible by itself, it's also divisible by 2. So 4 is divisible by some other number, so it's not a prime number, and so on, continue till 100. But actually mathematically it can be shown that you only need to check till square root of a number. If I want to check for the first 100 numbers, I only need to check for the first you only need to check by dividing the first 10 numbers. That's how it works. Okay, like let me try to show it to you. Yeah, so basically you can there is something called the square root of n to test for a prime. So here's the maths basically thing. So you just test all the primes lower than the square root of n, and then only you just have to check for only up to square root of n by dividing. You don't need to divide every number. Okay, so that's how usually computationally you do it. So here again, you only have to test whether it is divisible up to the square root of the number. And here you can see what is the kind of, justification for it. Okay, because basically if a number is not a prime, it will have two factors, a and b. So this anyway, one of these should be less than the square root of n. So you just need to check up to the square root of n. Okay, so that means when I check numbers for 100, I only need to divide from 1 to 10. I don't need to divide from 1 to 99 or something like that. So that is the kind of justification or the idea behind it. So that's why this school double into is there, because this actually justifies you're taking the power of it, because I have to take square root, right? So square root, how do I take? I raise something to the power of half. That's why this is 0.5, 2 asterisk. So that is actually correct. It's not wrong. Okay. Does everyone understand this? So this is just the algorithm, or this is just the check that you usually do. So here, what are they actually doing? They're dividing each position by all the numbers up to square root of n and checking whether any of them give remainder 0. If any of them give remainder 0, that means that they are divisible by some other number, which means they are not prime. They are composite numbers. So that is how they are checking. Okay. Does this make sense to everybody? Okay, great. Okay. So I hope you understand why this is in double asterisk and not divided by a single asterisk or anything like that. Okay. Try writing a program. Now you know how to write a program to check for primes, right? For if a number is prime. You can modify this program itself a little bit and you can find out how many primes are there. What is the first 100 primes or the first 1,000 primes or primes up to 1 to 1,000. You can all do that, right? It's very easy. So once you have the funda, once you have the algorithm for how to check if something is prime, you can apply it wherever you want. That's the beauty of programming. Like right now, this guy Nishan in the question, he wants to apply to snake and ladders. Prime numbers are very important actually because they are used in something called crypto. What is it called? Sorry, cryptography, right? Where when you encrypt something, usually it is encrypted in terms of a big number. So the prime factors are usually used to, break that number into two. So yeah, people are very interested for many reasons to find out what are the factors of a very big number and so on. You can look at that in your own time. But anyway, so this is about this question. Let's go to the next question. Again, this is again the same model of question where you have to find the error. So this is a line of code written using the library turtle. You have already used this library or module before. You know what it does. It's there to draw a square. In the absence of error, as before, enter the answer as -1. If you find there's an error, write which line has error. So this goal of this code is to draw a square. So please put your answers in the chat. Okay. So Vandana says -1. There is no error in the program. Others? Line 7 says Vikram. Other answers in the chat? Others? Okay. One more person saying there's no error in the program. Okay, line 7. Okay, I can see that people are oscillating between two answers, -1, 7, -1, 7. I don't see a majority. Is there a majority answer? Yeah, -1. Okay. -1 is the majority answer. Anyone else want to answer? Okay, -1. I'll give you one more minute in case someone else wants to try. Think we can go to the answer. I don't see anyone else answering. So majority of you are actually wrong. There is an error in this code. The people who said 7, you are right. So those of you answered line number 7, do you want to explain why the line number 7 is wrong, or what is the change that should be there to make this code correct? Those of you who answered, yes, correct, very good. Range should be of 4. Exactly, exactly. So here you can see range of 3. Yes, the loop should have four, square has 4 sides, so the loop should run 4 times, right? Forward, and then it should rotate right, then forward, then rotate right, forward. It should run 4 times like that, then only it will draw a square. Now, if you put range of 3 will give me what? 0, 1, 2. Because remember, range does not count the last number. So I have to give 0 to 4, then only it will count the last number also. Okay, because range always goes to n minus 1. Remember that. Okay, fine. I hope those of you who answered -1, you understand what is the issue now. Yeah, okay. I think you guys understand now what is the issue. Exactly. Range is not 0 to 3, it should be 4. The loop should run 4 times. Okay. Okay, fine. Next question. Okay. Like the spiral pattern, the metrics, any metrics can be printed in many patterns and forms. In the snake pattern, elements of a row are first printed from left to right, then from right to left, and so on. A crucial step in the algorithm to print the snake pattern is to check the row parity. Parity means the remainder when the row number is divided by 2, which means whether, what does that mean? Parity means whether it is an odd row or an even row, right? So identify the correct statements regarding this step. Assume the normal row indexing in the metric starts from 0. So here you can see the picture. I want to print the first row like this, second row like this, third row like this, and so on. Okay. So this is a multiple select question. So there are multiple correct answers, not just one option, multiple option are correct. So please read carefully and please understand what is parity and what should be the answer. Okay. Please put your answers in the chat. Give me a second. Okay, someone says B and D. I'm back. Yeah, B and D. Sorry, A and D. I'm very sorry. Other people? So parity is the remainder of when the row number is divided by 2. It's given here, right? Remainder when the row number is divided by 2. This is the definition of the row parity. Okay, I can see 3 people saying A and D. Vandana, I hope you understood what is parity. Yeah, okay, cool. So yeah, I'll give you maybe one more minute in case others are answering. You can see 3 answers, A and D. A and D. Okay, great. I can see most of you have said A and D. The answer is A and D. Very good. So remember always the only place where you'll make mistake is thinking this is the first row. Okay, this is not the first row. If we go by Python terms, this is zeroth row. So this will be 0, 1, 2. So the even rows are actually these ones and the odd rows is this one. So that's how we print it. Okay. Good. Everyone got that one right. Next question. Which of these conditions guarantee that the element is a boundary element of the matrix of order m by n? Take I as row index, j as column index to be checked. Okay. So boundary means it's either the first or the last. It's in the first row or column or in the last row or column. So here again, multiple select questions, so multiple options could be correct. Okay. Please check. The matrix is of order m by n and I is the row index and j is the column index. Which of these give us a boundary element? So either in the first row or column or in the last row or column. Okay, I see someone saying A and C. Okay, someone says all the options A, B, C, and D. A, B, C, D. One more A, B, C, D. One person says A and D. All. Okay, good. I think all of you are answering correctly. The answer is all of them because this basically gives you the first, this gives you the first row, this gives you the first column, and this gives you the last row and last column, right? So that's how you do it. Or actually, this gives you the first, uh, yeah, this gives you the first row. Yeah, exactly. So all of these are correct. So it should be n minus 1 or m minus 1 because even though it's m by n, we start counting from 0. So if it's a 2 by 2 matrix, then it'll be like 0, 1, and 00011011, so like that, right? So that's how you have to remember it. Okay, very good. Here, why do I need to write equal to and not just equal to? Anyone knows? This is not related to this question, but just because it's a condition. Exactly. So this is a very common error that people make when they write programs, is they'll write if I equals something. That is wrong, right? Whenever you write I equals something, you're declaring it. You're saying that I is equal to this. That's what Python reads it as. Whereas when you say equal to, you are telling Python check whether this is true or not, and then it will return you true or false. So whenever you're writing something as part of equality, as part of a condition, where you want to check whether it's true or not, you have to put two equals. Okay. Similarly, if you want to check if it's not equal to, you have to put that exclamation point with equal sign. Okay. Next question. Equal to for assigning, double equals for comparison. Very good. Good that you should, as you go to more complex things, you should not forget your basics. So that's very good. Okay, anyway, this is again the same format we had before. You know the drill, write the line number where there's an error. If there's no error, just put -1 as the answer. So given a set of 4 integers as input, the following code wants to print them as elements in the form of a square matrix of order 2. But the code may contain errors. Okay, so please try to check. So 1 to 13, or if you find that there is nothing that is wrong, then you can put -1. Okay, one person says -1. Others? I only see one person who has answered. Others, I hope you're trying to understand the program. Okay, one more person says 11. Other people? Any other answers? Okay, one more person says 11. Okay, one person says -1. Any other answers, guys? Come on. I'll give you one more minute and we can go to the answer. Okay, I think case two people say no errors and two people say error in line number 11. Let's see what the answer is. The answer is -1. This code works completely fine. You can also try it out if you want. So what it is doing is it's accepting, of course, four numbers as input once one by one, and then it takes the first two numbers. So numbers is a list. So the first two elements, that is 0 and 1, it takes as the first column, sorry, the first row, and the last two numbers it takes as the last row, right? So this up to 2 means 0 and 1. From 2 means it'll take 3 and 4, sorry, 2 and 3, right? Because that's how lists work. Okay. And then what is happening is for row in matrix means it will look for what are the elements of matrix. So elements of matrix means it has only two elements because it is a list of lists, right? So first list, second list. So each of them becomes a row. Then for the element in row means it will go inside the row and it will check, and then it will print each of the element, then end it. Okay. So this is how it works. So you can also try it out yourself and you can do it. Okay. I'll explain line 7 and 8 once more. So basically we numbers is a 1D list. Okay. It's a one dimensional list. 0, 1, 2, 3. Those are the elements. Imagine. Okay. Indices are 0, 1, 2, 3. This is okay. Numbers is a one dimensional list. Okay. We want to cast it into a square matrix, which means we want it to be like 0, 1, 2, 3. We want it to be 2D, right? We needed to have one list here and one list here. Instead of having one list of four elements, we need two lists of two elements each. So what they're doing is you're initializing a list of lists. So this is something called a 2D array or a 2D list, where each element itself is a list. Okay. And what they're saying is the first element, that is the first list, will have the elements of numbers up to 2. This is called list splicing, which you have learned when you learned lists. So if you put something like this, it means it considers all elements up to 2, but not considering 2. So I can show you an example. Let me just close this. Something unrelated. What is the thing? I think I forgot this in. Yeah, okay. It's like this. So you can see that when I give like this, it gives me all the elements up to index 2, but not considering 2. It's like range, right? When I give range of 2, it'll only give me 0, 0 and 1. Actually, it should return to me 0 and 1. Okay, fine. That doesn't work. So if I give like this is called list splicing. It basically gives me all the elements. If I give up to 1, then what will it give? It will give only the first element, because this is 0th element, this is the first element. Similarly, if I give like this, that means now you have to count the first element up to the end of the list. So 2, 3, and 4. Okay. Is this clear? Do you understand now what's happening? So here basically what they've done is they've assigned the first two elements of numbers, which is a 1D array, to the first list, the last two elements of numbers to the second list. And that itself is part of a list. So that's why this becomes something called a 2D array or a 2D list. Okay. Is this clear? Do you understand? Should I explain again? Do you understand? Okay, fine. If there's any more doubts, please stop me. I can explain it again. But yeah, best way is to like just do a little bit of experimentation, then you will also understand. So this is something called list splicing. This is very useful actually. When you run your, you want to access some elements of a list, it's very useful to do this kind of operation. Okay. So putting this and doing it. Okay. So yeah, please try it out. You can also try running this program and see what happens when I change these numbers and all that. Okay. Fine. Okay, next question. How do you write data to a CSV file using the CSV module? So you use the CSV module also this week, I think, in one of your programs. So again, a CSV is something called a comma separated values. So that is like a list of numbers or some data when you have, it's often stored in the form of a CSV, which is a comma separated list or comma separated values. So Python has, as I said, AstroPy helps me to deal with FITS files. Similarly, CSV, Python already has a module called CSV which helps you to deal with CSV files. So please answer in the chat. And this one, I don't think you will take time. Please try to answer quickly. Okay, someone says C. Okay, I see C and B in the chat. Okay, I think we can go to the answer. The answer is actually B. It's csv.writer. So even I didn't know about CSV module, but this is something that you can quickly look up. So let's try looking it up, right? So as I said, every module has a documentation page. So you can just go to the documentation page and you can see, for example, writer object. So you can see that csv.writer or CSV. Yeah, so here it is. CSV.writer is what basically writes into a CSV file. So that's why it's CSV.writer, not CSV.write. Okay. So here you can see an example of it. It's writing into the file with some delimiter, quoting, blah, blah, blah. Some other things are also used. So this is it. Okay. So the answer is C. Is that okay with everyone? So actually, sorry, the answer is B. CSV.writer is the answer. Okay. So you can just go and check in the documentation if you want.
So for writing, it's writer, and for reading, it's read.
Oh, it's read. Okay, I don't know about this module. I have not used this module before. I've only used pandas to write and read into files. But yeah, it's like it doesn't, sometimes it does not have like a fixed logic, right? It might be that the functions are named like that. So we can check here itself. How do we read? No, it's actually reader. The module says that csv.reader is used for reading. Do you see my screen?
Yes, yes. Okay.
So then it's reader and writer. I understand because some modules, maybe not CSV, some other modules they may use read and write. So yeah, that's why it's useful to always go. If you have any doubts, go to the documentation of that module and always go and check there because that is the source of it. Okay. Okay, great, fine. So now you know that in CSV module we have to use reader and writer. Okay, fine. Okay, so next question I think we have accidentally already answered. But yeah, please put your answers in the chat. I don't think this should take time at all. Yeah, okay. Good. All of you are answering immediately. Great. Okay. So I don't think I need to explain this because we just answered it. It is the answer is reader. Okay, good. All of you have answered. At least you're listening in the class. Okay, next question is about GM plot, which also you have used this week in your program on GPS, I think. So this is about identify which are the correct statements which regarding the GM plot library. So yeah, please put your answers in the chat. Okay, I think one person has answered C. I don't know if it's for the previous question or this. Okay. Oh, no, no. C, B, C, 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 A, C, C. Okay, I think we can go to the answer. The answer is both A and B. Okay, so GM plot is this is the definition of GM plot, and this I think you have again used in your program. Maybe I'm not sure. Again, if you have any doubts, we can just go to. Yeah. So here you can see how they have used that function, the latitude, longitude, and the sorry, latitude, longitude, and how much zoom you need. So they have already described how it works and how you need to plot. Okay. So yeah, I don't think there's any doubts right here. So yeah, both of these are correct statements. I think we can now go to the programming assignments that we have this week. So please keep your laptops ready. We have 1 hour, so let's try to do all of them if we can. And yeah, let's, as usual, I'll give you some time so that you can try it. And I always give time so that you can try it in the class. And if you face any issues, we can resolve it in the class. I have all the programs, of course, and I am sharing them with you, but always please try it yourself. That's the only way you can pick up programming is by getting your hands dirty with the code itself. Okay. So the first code is this one, or first program is this one. In spreadsheets, for example, if you use MS Excel, you know that columns are labeled like A to Z. After Z, it again starts as A, B, and so on, right? And until it goes to AZ. And then after AZ, again BA, again until ZZ. After ZZ, again it starts from the third letter. So basically, if you have this is the first column, this is the second column, and so on. And then, of course, after 26th column Z, the next column will be AA, which is a 27, then AB, and so on till 52nd column, which is AZ. Then next will be BA, because this is now changing, right? So now you given like these are some sample values, try to deduce the mapping between any column label and its corresponding number. So I will give you the column label as input, suppose ABA. Then you should give me this number as the output. Whatever ABA's number would be, you should give it as the output. Okay. So this is the program. I think it's not that difficult to understand. Try to think about how you'll do it. And I'll give you 10 minutes, 15 minutes, and please try it out and we can look at the solution together. Okay. Any doubts in this, in the program itself? Any doubts? Does anyone have any doubts in the program? Okay, I think not. So let me just show you the program again. Please try it yourself. Okay, I'll give you 10 minutes maybe. I think 10 minutes should be fine. And then we can look at the solution. Okay. Are you guys trying it? How many of you are trying the program? Okay, good. I'll give you 5, 6 more minutes. Please try it sincerely, and we can discuss the solution after that. Okay. Okay. Okay, Satya. No issues. I just saw your message. I'm not that proficient in Python or the logic. That's good. Logic is the most important thing. Okay, but you should keep trying at least to write the program, because then when you're coming through some issue, we can do it. So maybe let's wait for 2 more minutes. Then we can go to the solution, and you can see whether your logic is matching. Okay. So it's not enough to have logic. We need to also know the syntax little bit. That's why Python is good, because it doesn't have a lot of syntax like other languages, and it is easier to pick up. So please try to pick up. But yeah, logic is very important as well. So it's good that you have that aspect down. Okay. Let's wait for 2 more minutes, and then I'll show you the solution. Okay. Others also keep trying. Okay, maybe we can go to the solution. Any of you who are trying, please keep trying, but I'll just discuss the solution once. Once again, please, even if you see the solution, try to implement it on your own. Because many times what happens is when we hear the solution, we can understand it, we see that we get the logic of it. But when we try to write it only, we'll make some issue or error, and then only we can easily, then only we will learn. Okay. So please try it out like that. So I'll just open my files. One, sorry. Okay. Sorry, one second. Yeah, okay. I think you guys can see my screen. You can see the program. I'll just make it bigger. Okay, fine. So here the question was, if you look at it, oh sorry, yeah, the question was that we have to find out what is the number which corresponds to the letter, right? If it's A to Z, it's very easy, just 1 to 26. After that only we have to keep counting like 27, 28, like that, right? So that is where it becomes little more complicated. So first of all, we are assigning numbers to all the letters. So here you can see that we have defined some function to map the letter to the number. So we have made A, B, C, D, E, F, G, H, I, J, etc. And for each letter, it will return the index plus 1. Why plus 1? Because as you know, this first character in Python will be considered as 0 index, right? But we want this to be 1. We want A to be 1 and Z to be 26. If you don't put this plus 1, A will be 0 and Z will be 25. So that's why plus 1 is run. So now we have defined a way to map a single letter to the number, right? Now what we are going to do is we are going to take the input and we are going to define a recursive function. So why do I call this a recursive function? Again, last week we discussed what are recursive functions. It's when I define a function in terms of itself. So here you can see that I'm defining this function called num, but you can see that in its definition itself I have that function called again, because actually what is happening, why do I need recursion in this case? I have to, sorry, I keep opening the wrong tab, I have to call this multiple times, right? I have to call letter once for the first letter, then I have to call it again for the second letter, and if there's a third letter I have to call that function again. So that's why inside this I have a recursive function which is actually calling itself, and every time it's actually calling. So you can see that I am taking the label and the length of the label. Of course, if the length of the label is 1, that means I just have a single letter. It becomes very easy. The value which this returns, that is just the answer, right? Whereas if there is more than 1, then what I have to do is value into 26 into n minus 1. You'll understand why 26 in a 26 into n minus 1, because 1 to 26 goes and then only the next one comes, right? And then the call num of the rest. So what happens is it keeps calculating. If I give a, first it will calculate what is a, then a, then a. So a, it knows it's 1, then a, it knows it's 1 plus 26 into 2 minus 1, so 27, right? Then it knows 27 plus 26 into 3 minus 1, so it has to calculate like that. Okay, so that's how it works. So is this logic clear to everybody? Do you all understand why it's like this? It's a simple program. Do you understand why the logic is like that? I have to call it again. Okay, great. I'll explain it again. No issues. So here what I'm doing, what does letter map do? It just assigns a number to every letter. Okay, that part is fine, right? If I just, suppose I run this program and I just write A, then it's 1. Okay, or if I run it and I write Z, then it's 26. So this function is clear. It just assigns a number to the letter. Now, if I want to calculate what is the number of A into AA, what is it? It is 1 to 26 and then only 27 comes, right? That means after 26 numbers, I have to consider AA, right? So what this can be written as is basically 26 into n minus 1, okay, or 26 to the power n minus 1, sorry, plus column number label. So basically it tells you that 1 to 26 is over. So now you have to go to the next part. Okay, so that's why you have to take it as a power. For example, when you are very young, in younger classes, you would have done this place value and face value of numbers, right? Do you guys remember? If I give you a number like 135, for example, then you will write it as 1 into 100 plus 3 into 10 plus 5 into 1. Have you all done this? Maybe in first or second standard. Have you all done this? Yes. Okay. Here, that was a number system of base 10, right? We have 1 to 10 and then it starts again. Or we write 1 to or 0 to 9 we have, and then it starts again 1 0 1 1 1 2 1 3 1 4 until 1. Here we have base 26. Okay. So that's why it's 26 to the power of n minus 1. Got it? So here we have A to Z. Imagine A to Z are numbers, right? Then it'll be 0 to 9 and then 1 0 1 1 1 2. The same concept is here. Here instead of 0 to 9 we have A to Z. Then we have A B and so on. So that's why it's 26. I said 26 into n minus 1. I meant to say 26 power n minus 1. That was my mistake. But basically what I mean is that you consider powers of 10, right? You consider 1, then 10, then 100, 1000, 10,000. Like that, here you're considering 26, 26 square, 26 cube, 26 power 4, etc. Okay, so this is the idea. Is this clear for everyone? Go from the end of the label, make a variable 0 for the unit place. It's just adding the character, then go to the left, it'll be 26 square. Likewise move, increase the power. Exactly. So you have got the concept. And the reason why we call a recursive function here is now every time you're, to find AAA, we first have to find AA. Then we have to find A. That is how they are calculating it. Okay. So that's how you're doing it. You can do it without recursive function also, but it's a good idea to use recursive function. You just learned it. So it's a way to implement something that you learned. Okay. Does everyone understand this? Just recall it to your base 10 number system. Then it's very easy. Okay. Is that clear for everyone? Okay, great. Okay, nice. So yeah, this as you saw, writing the program is somewhat okay. Like you can, yeah, of course, it's difficult sometimes to find out how to structure it, but getting the logic is also very important. So try always to, try to think about the program first. Don't just go into write it. Once you get the program, try to write it. If you don't know something, you can look it up. That's fine. But yeah, always have the practice of writing your own programs and getting the answer yourself. Okay, both of these should be done by you. Then only you're a good programmer. If you're just implementing solution which someone is telling you, you're not, you're nothing. You're just a computer, right? You're just chat GPT. But if you're actually sitting and thinking about the program, that's what makes you a good programmer. Okay. So two aspects are there. One is the logic and one is the syntax. Both you should have developed equally to be good programmer. For that, there's no shortcut. The only answer is to do many different kinds of programs. And that's why these sessions and your classes are held. So you get exposure to many kinds of programs. Okay. So let's go to the next question. Okay. So this is the next question. So there is a queue at a fast food restaurant which operates in the following manner. Okay. The queue is a single line with its head at the left end and tail at the right end. A person can exit the queue only at the head and join at the right. So you can imagine it to be a queue means it's a bunch of numbers, right? There's first person, second person, third person, so on. So it can be something like 1, 2, 3, 4. We are going to call head as the, sorry, left and right. So this is head and this is tail. Okay. And they are going to, each of them is going to have a token. So 1, 2, 3, 4, etc. Let's say it's 1, 2, 3, 4. It doesn't have to be, as you will see. At the point of entry, each person is assigned a unique token. You have been asked to manage the queue. So yeah, you can do these following operations on it. So there is a joining, which means one person adds to the last end of the queue. Leaving means one person leaves from the front of the queue. Moving means moving some person who's in between to the head, but you can also have move of two kinds, which is moving someone with in between to the tail. And printing means printing the queue as a sequence of comma separated token numbers. Okay, the head comes to left, tail to the right. So suppose 1, 2, 3, 4. Print just shows you 1, 2, 3, 4. So Q is empty to begin with. Keep accepting an operation as input from the user until the string end is entered. So basically, you are like a manager of the queue. You are just writing the commands like join this person, leave this person, move this person until you write end. When you write end, the system understands that the queue is over. I don't need to do any more functions. So this is the way that you write. So use some list functions. Please try to do it yourself. It's a little, I know it's a little involved. I'll give you a little bit of time. I'll give you 10 minutes and then let's discuss the question together. But please try to think about how to do it at least. Okay. As I said, thinking about the solution and this both are important. So for example, this is one of the example outputs, right? So you're joining one, joining two, joining three to the queue, then you're printing. So you can see one, two, three, they are all joined to the queue. Every time you give join, it adds to the last. So it's just like a real queue, right? You can only enter at the last end of the queue. So first one is entered, then one, two, then one, two, three. And when you print only, you're able to see it, right? Then you're moving 3 to the head, which means 3 comes to the front of the queue. Then you're printing. End means the operation is over. So you have to write a program where it keeps accepting these operations until you give end. So you have to write functions for each of these problems, each of these sorry, not problems, each of these actions, and keep accepting the function or keep accepting the input until you write end. Okay. So please try it out. I know it's a little different than what you have done so far. Please try it out and see if you can do it. And let's see. Okay. I hope you guys are trying. I'll give you like, yeah, I'll give you a few minutes actually. Try it. And then we'll discuss. I hope you all understood the question. And are there any doubts? Okay, fine. No issues. Uh, No issues, Muskan. We'll discuss the solution. Others also, please try those. So you have already had a session about queuing and all that. Then it might be a little easier. I didn't know that. So yeah, others also please try. I'll give you maybe 2-3 more minutes and then we can discuss the solution. Are you guys trying? How many of you are trying? Please raise hands. Okay, good. Others also please try it. I'll give you 5 more minutes and then we can discuss the solution. Sorry, is there a question? There a question? Hello? I'm muting you. I think by mistake. Please don't unmute if you don't have a question. It's very distracting. If you have a question, please unmute or you can write it in the chat. Okay, maybe we can go to the solution. Those of you who are trying, please keep trying, but just look at the solution and we can discuss. Okay, so here is the program. Let's go through it step by step first. So again, so basically there are four options that we have to define and the print statement. Okay. And this operation have to keep happening until end is entered. So that's what this example means. Joining is one function where the token number is added to the queue at the end of the queue. Leaving is when it moves from the head of the queue. So move just moves either to the head or the tail depending on what we specify. Okay. Okay. So let's try to look at the program. Okay. So you can see that we are putting enter operation. Okay. And it keeps going until you write end. Right. So while operation is not equal to end, and if operation is join, then append to the queue. Append means we are adding an object to the end of the list. So that is what joining means. If object is leave, then you pop Pop means you're removing from the end of, from the beginning. Okay, so return item as index, define last. Okay, okay, yeah, from the end of the queue. Sorry, yeah, basically from, why is it the end of the queue? Let me try to remember. Okay, okay, okay. Sorry. So here you can see that it's given pop of 0, right? So that means that, so here you can see the thing, right? It removes and returns the item at index whatever we specify. So here the index is 0, which means we are specifying that we have to remove the item from the first index. Okay. So that's what leave does. So join and leave are done. Otherwise, if operation is move, then what you're doing is you're removing that member, which means you're removing that first occurrence of that value from the list. And if the of the after move we are writing tail, then it inserts it at the end. Otherwise, it inserts it at the starting. And of course, if the operation of 0 is print, then we are just going to print everything with the cube, right? Join means we are just going to concatenate all the numbers together, and then we are going to do. And of course, after that, again, we have to enter operation. We have to keep going. So why do we need to specify operation of 0 like this? Can anyone identify? So you understand, right? This OP is basically the operation, join, leave, move, all that. Why do we need to specify operation of 0 is end or operation of 0 is join? Why not just operation equals join or operation equals end? Can anyone identify? Okay, should I repeat the program or the question?
Can you repeat the question? Yeah.
Yeah, the question is, so do you see this? I'm saying operation OP. This is the variable which stores what operation I need to do, join, end, leave, or move, right? Now, you can see everywhere I'm checking the equality with operation of 0. Why do I need to check with operation of 0 and not just operation? I mean, sorry, not operation OP. Why do I not just check with OP? Why do I check with OP of 0?
Because it's in an array, maybe the queue we have declared it. So
No, OP has nothing to do with the Q, right? The Q is different. Q is different, right? Q is going to be stored in this variable Q. Because there's multiple operations, so what? Every time I'm rewriting OP, right? Every time I'm rewriting OP, why do I need to only consider the first operation? I have to check each time, actually, I have to check the latest operation. Are you saying that OP stores all the operations that are there? I don't think so. So the answer is actually very simple, and you can see it when if you look at the move statement. Okay. The reason why I need to consider OP of 0 is because as per the question, okay, it's not because of the latest input to be considered. Actually, if you check this program, OP gets rewritten every time. So it's nothing to do with latest input or anything. The reason is if you look at this loop and then if you look at the question, one of the operations or more of the operations like join, move, and all, they have multiple parts, right? Join, and also you have to give the token number. So it checks first for join and then it checks for the token number. Similarly, in move, this is OP of 0, this is OP of 1, and this is OP of 2. There are three parts to the operation. I have to first check whether it's move, then I have to check which token I have to move, then I have to check whether I have to move it to the head or the tail. So if you look at this loop, sorry, if you look at this loop, you can see that first I'm checking whether the statement itself is moved. Then I'm saying, okay, the member or the token which I have to consider is OP of 1. I'm removing that member and then I'm checking whether it says tail or it says head. So here it's assumed that if it's not tail, it's head. So that's why it's like inserting. Does everyone understand? Does everyone understand? It is not because many operations are given and we are giving the latest one. That is not the case, because every time if you see this function, it is actually rewriting over OP. It is not storing all the functions we have given before it. What we are actually doing is, because there are certain commands like join and move which have multiple paths to their operation. So that's why. So similarly, if you look at join, you can see that join of op of 1, whatever token we are entering, it appends that token. Okay, so this is the idea. So whenever you have a program, try to ask yourself these things, right? Even if you're not writing, if you're writing the program, that's the reason you need to write a program. When you write the program only, you'll realize like, oh, I can't just accept op as a single string. I should actually accept it in parts, because there are three parts to move operation. So every time I have to check whether if it's move, I actually have to check all three parts. If it's join, I have to check two parts, right? So I have to accept string such that it is able to store three parts. So that's the kind of issues that will show up, which are not obvious when we read the question. When we read the question, what do you think? We have to write three functions, that's it. But when we sit and write the function, we realize that it is more complicated than we thought. Okay, so that's why I'm telling you again and again, please try writing the programs on your own. Even if you don't write the program and you have the program given to you like this, don't just blindly run it or copy it. Try to ask yourself question, why should it be op of 0? Why should it not be op of, why can't it just take it as a string? Is there any other way to do it where, I can enter the operation, then check if it's move, then if it is move, I can prompt the user to again enter. I could do something like that. But the question that was given to us was that you have to write move comma this comma head, or move comma this comma head tail, right? So that's why we had to do it in this way. Okay, is this clear to everybody? Does everyone understand? So this is the logic of the program. Let's check if it's actually working. So I gave a model input here, right? So let's try running this sequence. Okay. Okay. So let's run. So the first thing is join comma 1. So let's put, okay. Then join comma 2. So again, until I write print, it's not going to print, right? Join comma 3 and then print. You can see 1, 2, 3 is printed. So that is the current status of the queue. Now, if I move, again, three parts to this command, move 3 to the head. And then if I print, you can see that the queue's order has changed, right? And until I write end, it will keep asking me to enter the next operation. Okay. Does everyone understand? Is this clear to everybody? Where is the teams? Is this clear to everybody? The functioning of this program? I hope those of you who didn't know about queue structure before, you can kind of get an idea, right? Queue is nothing but a list. And we just need to know that pop means those functions like pop, append, those are list operations. So once you know those things, it becomes very easy. Okay. Please try to do this program or such programs on your own. These are actually very useful. You can think of, maybe a restaurant or something where such a system would be very useful to them, right? So yeah, these are programs which have real life applicability. Okay, let's go to the next program. I'm hoping there is no doubts in this current program. So I'm going to the next program. Okay. Accept a series of lowercase letters from the user and encrypt it using the following image. So whenever I write A, it should be replaced by Z, B should be replaced by Y, C should be replaced by X, and so on. Okay. So until M should be replaced by N. So basically half of the alphabet. The first 13 letters should be replaced by the, last 13 letters in this sequence. Each letter in the string that appears in the upper half should be replaced with lower half and vice versa. So if I have Z, that should be replaced by A, Y should be replaced by B, and so on. Print the encrypted string as output and accept it as input. Okay. So again, try doing this. I don't think this is very complicated. I'll give you 10 minutes. Please try this program. I hope you guys are trying. How many of you are trying? I'll give you 5 more minutes. Okay, good, good. Keep trying. Those of you who are trying, I'll give you 6 few more minutes. Then we can look at the solution together. Okay, maybe we can go to the solution. Uh, did any of you get the solution after trying? Any of you? Okay, no problem. We'll try to look at the solution together. Okay, so let me just take the program. Okay, so you can see that it's not a very big program. It's quite simple. Okay, so here you can see that we enter the word and you have all the letters in order. And what you actually do is you take the index to be of the letter. Suppose it's A, and then you just put the output to be whatever is letters minus index minus 1. So my as we discussed in one of the earlier classes, minus starts counting from the back of the array, right? So let's try this again. So here we have A of 1, 2, 3, 4. If I now give A of minus 1, it will give me 4, the last element. If I give A of minus 2, it will give me the second last element, which is 3. So if you give minus of something, it starts counting from the back. Okay. So here the index is like 0, 1, 2, 3. Same way, if I want to count backwards, it's minus 1, minus 2, minus 3, minus 4. So if I give A of minus 4, it becomes like this. Okay, does everyone understand that? Does everyone understand this? Minus index means you're counting the array backwards. Okay, I think we had discussed this in one of the classes also. One of my problem solving classes, we had discussed this issue, maybe last week only. Okay, so now what we are actually doing is we are taking the index of A and we are saying that the output is going to be the letters of minus index. So that means if I'm having A, then it will be A's index is 0, so it will just be -1, so the last letter. If I take something like C, it will be C's index is 0, 1, 2. So the corresponding index will be -20, -2, -1. So the third letter from the back. So if I consider the third letter from the front, this is basically telling me consider the third letter from the back. I have to put -1. Why do I have to put -1? Because when I count the index forwards, I start from 0. I say 0, 1, 2, 3. But when I count it backwards, I start from -1. -1, -2, -3, -4. So 0 and -1 should be corresponding. 2, 1 and -2 should be corresponding. So that's why there's this extra -1. Suppose I give Z, what happens? If I give Z, I know Z's index is what? 25. So what happens? This will become -25 -1. But -25 -1 is what? -26. -26 means it will go -1, -2, -3, -4 until the start of the array. So again, it reads backwards until it reaches the start of the array. Similarly, if I give X, X's index is what? This is 26 letters. So this is 25, this is 24, this is 23, right? So -23 -1 means 24. So it will go back 24 steps until it reaches C. Okay, so this is how it works. Does everyone understand? Is this clear to everybody? It's simply equating the front reading of the index and the back reading of the index together. That's all. It's not very complicated. All we used is equating the front reading and back reading together. When we read the index from front to back, sorry, start to end, we start from 0. When we read the index from last element to the first element, we start from -1. So that's why we had to put this extra -1 to keep that difference. Okay. So this is all. We can try it out now. If I put something like A, no, sorry, my bad. A, B, C, D, it gives me Z, Y, X, W. If I give my name, it gives me Z is A, E is V. Okay, it gives me some complicated thing. But yeah, basically it works. And if I give something like Z, Y, X, W, it should give me A, B, C, D. It gives me A, B, C, D. Okay, so this is the program. Is there any doubts in this, or shall we move to the next? I think we have only one more program, and I think we have time for one more program. Okay, great. So let's try to do the last program also for today, and then we can end the class on time. Okay, this is the last program. Write a Python program to convert decimal to binary using recursion. Okay. In case any of you don't know, binary is base 2. And the way that you convert binary decimal number to binary is by dividing the number by 2 and printing the remainder in reverse order. So for example, if I have the number 34, then you can see that I keep dividing it. So 34 divided by 2 is 17 with remainder 0. 17 divided by 2 is 8 with remainder 1. 8 divided by 2 is 4, so on. Write all the reminders. Then the number just becomes 1000010. So you have to go in the reverse order. Okay. So basically, you have to divide by 2, collect the reminders, print it in the reverse order. You have to keep dividing by 2 and collecting the reminders. This is how you write a decimal to binary. It's an easy program, but I want you to try using recursion. Just to remind you, we spoke about recursion last class. Recursion is basically when you define a function in terms of itself. We used it when we defined that base 26 AZ program, the column numbers program. So why don't you guys try this? Maybe I'll give you a few minutes and then I'll show you the solution, and with that we can end today's class. Okay. Please try it. Uh, please try this and we can end today's class on time. I'll give you guys 2 more minutes. Any of you are able to? Is there a doubt? Okay. Yeah, I'll give you a few more minutes. Please try it out. And otherwise, we can go to the solution. Okay. I'll give you 2 more minutes. Is there a question? I'm going to mute you if there's no question. Okay, maybe we can go to the solution. Are any of you still trying? Or shall I go to the solution so we can end the class on time? Okay, someone has given the solution in the chat. Very nice. Check with this example of 37. If it works, that's very good. I think that is my cue to show the solution. Others also. So you can see that your friend who has posted in the chat, they have defined the function decimal to binary, but they have also used decimal to binary in the function definition. So please just try it out if it's working for 30, sorry, not 37, 34. If it's giving this value, please try it out. Okay. I'll also show the solution in the meantime. So basically here you can see 10 is greater than 1. So, okay, whenever you have divide by 2, that basically tells you that you have integer division. Okay, so for example, if I give 17, or I'll give it here. It's probably more visible here. If I have 17 divide by 2, it gives me 8. Whereas 17 divided by 2 gives me 8.5. So this double slash always gives me the integer part without the remainder. Without the decimal, it gives me the part. So here basically every time you're dividing by 2, if you look at this, I have to get only the division, whatever is the quotient. So this basically gives me the and this n mod 2 gives me the remainder. Okay, so now if I run this, you can see that, oh, what's the issue? Oh, okay, sorry, I'm still in Python. Clear. Now if I run this, you can see that gives 10010, and that is exactly the number which we were supposed to get. So here it is just basically printing the reminders and giving me that. Okay. So this is how you do the program. Okay. So is any doubts in this? This is a very simple program. Main thing is to just realize that you can define it in terms of each itself, because to find 34, you need to find 17. To find 17, you need to find the next divided by 2 number and so on. Okay. Okay, I think there are no doubts. Then we can end the class for today. Basically, we looked at a few different programs today and questions also. Are there any doubts at this stage, or shall we end the class? Okay, let me just go back to the first slide. So as always, if you have any doubts, please mail me. I'm free to throughout the week. You can mail me at any time. I'll respond. If you want some certain problems or concepts to be cleared in the next class, you can mail me. Up to Friday, if you mail me, I'll be able to incorporate it in the next week's class. Okay. So by Friday, if you have some particular program, suppose some concept which was explained, you want to explain again in the session. Because again, these are interactive session. They are meant so that you can interact with me and get actual doubt clearing what you want. Okay. So please take advantage of it. This is my mail ID. And this is my link where I have all the slides, and also I upload all the programs that I discuss every week. Sometimes even if I don't have time to discuss the program, I still upload the program. So please go through the slides and the list of Python files that I upload every week. It's for your benefit. I also have the YouTube videos which are linked. In case any of you miss any of the sessions, you can also go and refer to on YouTube, right? So here is the link basically. Sorry. Yeah. So here's a link. I think that's it for this class. We have discussed the programs. Any doubts? Any last comments by anyone? If not, let's end the session. Okay. So bye everyone. Thanks for joining and see you all next week, same time. Okay. Have a nice rest of your week. Okay. I'm ending the meeting.